So what we're going to look at next in regards to some different things with polynomial division are just some different aspects of synthetic division and some different theorems that go with synthetic division. So one of which is what's known as the remainder theorem. And the remainder theorem basically is involved with synthetic division, and you can use the remainder theorem to evaluate a polynomial function. So for instance, one of the ways that you could substitute a number in for x into a function and determine what its value is through order of operations, which is what you're most accustomed to doing for problems like that. But you can also use synthetic division to evaluate a polynomial function for a given value of x. And that's what this first example on here refers to. So the question says, use the remainder theorem to evaluate the following function at x equals -2. So when I go to do this here, what I'm going to do is I'm going to set this up as a synthetic division problem where -2 would be the value of k, and what I would put inside the synthetic division box are the coefficients of f of x here. So I'm going to have something that basically looks like this. I got -2 for k, and then just remember, you always want to check to make sure you have your dividend in perfect descending order. So I got cubed, squared, x, and then the constant at the end. So that's good there. So I got a 3x cubed, 8x squared, positive 5x, minus 7 at the end. So one of the ways that I could do f of -2 would be to do synthetic division where k equals -2. So if I start off by dropping the 3, and then I'm going to multiply here -2 times 3, and I get -6. And when I add those together, I get +2. And then when I multiply again, -2 times +2, I get -4. When I add those together, I get +1. And then finally, when I multiply -2 times +1, I get -2. And when I add those together, I get -9. And that's the answer for this particular problem here. So if I was going to do f of -2, the answer to this would be -9. Meaning, if I were to substitute a -2 in for x here, here, and here, and do the order of operations, this is the answer that I would get when I do that. So remember, you can check this on your calculator by doing the whole stored number thing. So if I exit out of this here and I go to my calculator and I just store the -2 in for x, and then I type in the function, which was 3x cubed plus 8x squared plus 5x minus 7, what I should get here is -9. So it's just a different way to substitute and evaluate an x value into a function. So that's what the remainder theorem says. The other theorem that goes with synthetic division is what's known as the factor theorem. And the factor theorem is what we can use when we're talking about trying to take a polynomial function and use synthetic division to create a function that's easier to factor. So the factor theorem says that whenever you do synthetic division and you substitute a value in for k, if the remainder ends up equaling 0, if the result is 0, then what we would say is x minus that value of k is a factor of the polynomial. And we'll talk about a couple different examples of that. So if the remainder is 0, that means that x minus k is one of the factors of the polynomial function. So when I go to do something like this here, and the question says show that x minus 2 and x plus 3 are both factors of 2x to the 4th plus 7x cubed minus 4x squared minus 27x minus 18, then find the remaining factors. And this is, in a lot of instances, what we use synthetic division for in terms of factoring. We try to take something like, for this instance, that's x to the 4th power, and if I do synthetic division twice for this, that's going to turn it into something that's a quadratic function that's x squared, and then from there I usually can find a way to factor something like that a lot easier than what the original polynomial function is. So I'm going to start off first by doing x minus 2. So the value of k here, let's put this up here, the value of k for this is going to be positive 2. So when I set this up, I got a 2 here, and then I got 2x to the fourth, positive 7x cubed, negative 4x squared, negative 27x, and negative 18 at the end. So when I drop this 2 here, 2 times 2, that's going to be 4. And then when I add 7 plus 4, that's 11. And then 2 times 11 is 22. And when I add negative 4 plus 22, I get 18. And then 2 times 18 is 36. And when I add negative 27 plus 36, I get positive 9. And then positive 2 times positive 9 is going to be positive 18. And when I add these together, it equals 0. So that shows now, since the remainder for this is 0, that shows that x minus 2 is one of the factors of this polynomial here. So if I tried to factor 2x to the fourth plus 7x cubed minus 4x squared minus 27x minus 18, x minus 2 is going to be one of the parentheses that you're going to get when you try to factor that. But then I also want to check to see if x plus 3 is also a factor. So in terms of the value of k, if it's x plus 3, the value of k is going to be negative 3. So what I'm going to do is I'm going to take the result that I got when I did the synthetic division from when k was equal to 2, and I'm going to work right off of this, and I'm going to put a negative 3 in for k. So when I do that, I'm going to drop the 2, and I'm going to do negative 3 times 2 is negative 6. And when I add those together, I get positive 5. And when I do negative 3 times 5, that's negative 15. And when I add those together, I get positive 3. And then when I multiply negative 3 times 3, I get negative 9. And when I add those together, it equals 0. So since the result from that is 0, that tells me that x plus 3 is also a factor of the polynomial function. So keep in mind that when you get this result at the end, 2, 5, 3, remember that because I did synthetic division twice and I started off with a function whose degree was 4, once I did synthetic division twice, I took this function, and now the result here is going to get me a quadratic. It's going to get me an x squared term. So the result from this is going to be 2x squared plus 5x plus 3. So what I want to do then is I want to find the remaining factors. So I'm going to take this here and I'm going to factor this. So let me kind of go to the clean page here. So keep in mind what I have here as far as the factors go. So I already have x minus 2. I know that that's a factor. I have x plus 3. I know that that's a factor. And then I also have the result that I got from doing synthetic division, which was 2x squared plus 5x plus 3. And what I want to attempt to do is factor this. So when I do that, I got 2x times x. I got a 3 here and a 1 here, and they're both going to be plus signs. So to just check this to see if I'm right, when I do 2x times 1, that's 2x. 3 times x is 3x. And when I add 2x and 3x, I get 5x, which is what this is here. So that's good. So when I'm asked to find the remaining factors are these two factors here. Let me sort of just put this down here. Remaining factors are two x plus 3 and x plus 1. Those are the remaining factors there. So when you get to the end, how do you know if you're right? That in fact those are the remaining factors. So there's a couple different things that I could do here. One is, and I think this is the easiest, is I'm just going to do the storing number thing here. So let me come to my calculator. So once again, I'm going to pick a number for x. I'm not going to choose 2 though, because if you notice in the question I have one of the factors as x minus 2, and if I put a 2 in for x, that's going to make the whole thing equal 0. So let me pick a different number for x here. So maybe I'll put, I don't know, say like a 5 in for x. So if I store that in, And then what I want to do first is just type in the original function, 2x to the fourth. So I've got here 2x to the fourth plus 7x cubed minus 4x squared minus 27x, and then minus 18 at the end. Get an answer, and then type in what we said the factored form of this was. So that does include the two factors that were given in the question, the x minus 2 and the x plus 3. And then I'm going to put in what the remaining factors that I found from using synthetic division, which was 2x plus 3 and also x plus 1. So when I put that in, I just want to make sure that the answers match when I do that, which it does not. Oh, I put in 2x minus 3. This should be 2x plus 3. So let me come back here. Let me fix that. This should be 2x plus 3, not minus 3. So now that should work. 1872. There we go. So that's just something you can do to check yourself when you get to the end there for that. So just finishing up with a few things here involving the uses of the remainder in synthetic division. So just remember that the remainder r gives the value of f at x equals k, and that's what the remainder theorem basically says, is that the remainder that you get when you substitute that number in for x, the value that you get is the remainder when you're doing the synthetic division. Some other things, if the remainder is 0, so remember that if the remainder is 0 when you do synthetic division, that means that x minus k is going to be a factor of the function. Also, if the remainder is 0, what that means is the value of k represents an x-intercept on the graph of the function. So that's sort of another thing that kind of ties into the factor theorem there. So that's just some different things that are involved application-wise with some different theorems with synthetic division. There's the remainder theorem, there's the factor theorem. The factor theorem is going to be a very important tool that we're going to use when we get into looking at some different things with finding the zeros of a function, finding the x-intercepts of a function, and things of that nature there.